Hi guys, so in this video we're going to be talking about the idea of a unit vector. Unit vectors, very simply, are vectors that have a length of 1. So this could be any vector, doesn't matter what it is, but as long as its length or its magnitude comes out to 1, we would call it a unit vector. Now in particular, there are 3 unit vectors that we find really interesting and useful. So we refer to them as I, J, and K. You might have seen I and J before. So I basically has an X component of 1 and the other 2 components are 0. J is the same, but its Y component is 1, and K is the same, but it's got a Z component of 1. And if you think about what these represent, let's just draw up a 3-dimensional axis to start with. So we've got X, Y, and Z. If we plot these over the top of our axes, you would see that the vector I lies directly on the x-axis, J lies directly on the y-axis, and K lies directly on the z-axis. So why is this useful? Well, it gives us another way of writing out vectors. For example, let's have a look at the vector 4, 1, -2. If you think about it, one way of writing that is that we've got 4 lots of 1, 0, 0, plus 1 lot of 0, 1, 0, and then -2 means take 2 lots of 0, 0, 1. Because if we think about doing the scalar multiplications here and then adding them, we would end up with the vector that we started with. So another way of writing this would be 4 lots of I plus 1 lot of J, take 2 multiplied by K. So you may see 3-dimensional vectors such as this written in this format here, where we multiply each component of the vector by I, J, and K. Okay, what else can we do with unit vectors? So let's just have a look at another example. Let's say we've got some vector here, and it's not a unit vector, it's a big long vector, and we're just going to call it A. And I'm going to say that this is quite a long vector. The length or the magnitude of A is going to be 3. Well, let's think about, what if we said, I want to have a unit vector that goes in the same direction of A, but is a unit vector. So we're going to call that U. So U is a unit vector in the direction of A. Well, how would we figure out what U is? What we could do is we could say that U is exactly 1/3 the length of A, but in the same direction. So we would multiply each component of A by 1/3. And another way of writing that would be 1/3 times by A. Or in other words, what we're doing is we're multiplying A by 1/, the magnitude of A. And that makes it a unit vector. Let's have a look at a little example. So, e.g., find a unit vector in the direction of a vector called B, which has components -3, 1, and 1. Well, what we would do in this case is we would say, let's work out first of all, what is the actual length of B? Maybe it is a unit vector and we don't have to do anything. So that'll be the square root of -3 squared plus 1 squared plus 1 squared, which comes out to the square root of 11. That's not 1, so it is actually not a unit vector, but we can figure out a unit vector. So I'm going to call the unit vector U, and that's going to be equal to 1/, the modulus of B multiplied by B. So in this case, that's 1/√11 multiplied by our vector b. Now there's not much we can do here, so it's just going to be -3 on root 11, 1 on root 11, and then 1 on root 11 again. And this vector that we've ended up with here at the end is actually a unit vector. If you're able to, if you wanted to go through and work out the length of this, you would find that the length of that vector, the length of u, is going to be equal to 1. But if we plotted it up against b, we would find that they go in the same direction. Okay, so I hope that makes sense. If you've got any questions, let me know. Thanks for watching.